Hello everyone, welcome back to Let's Crack JEE, the channel of Unacademy in English. Alright, so let me start with my introduction. And also let me check my voice. Yes, it's alright. Hello. 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 So, okay. So I think it is perfect. Okay, so I am Jeetendra Dixit. I did my B.Tech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for the last 11 years. And before starting, we were doing quadratic equations and I'll continue that, quadratic equations. Today we'll do fourth degree equations which are convertible to quadratic, all types of fourth degree which we can convert into quadratics, and we will solve it, okay? So learn those forms, but before starting, let me tell you about the Unacademy subscription. Alright. So as you know, Unacademy is India's largest online learning platform. And once you get the subscription for IIT-JEE, okay? So let us talk about IIT-JEE. Then you get access to daily live classes of all the JEE educators, all means physics, chemistry and maths. And they are live and recorded sessions, all live and all recorded sessions you will be able to access. You can interact with those educators during the live sessions through chat, and you can send your doubts. There will be dedicated doubt sessions as well. Also, you can attend special classes before subscriptions to get the feel. Okay, so special classes are free. So whatever special classes you can see, you can attend that class. So you'll get familiar with the platform of Unacademy. Apart from this, live tests and quizzes will also be available for you. So you can access all live tests and quizzes, PCM based test, right? So all these things, and everything is well structured. I mean, like course plan, you can see every like upcoming lectures. So details of all the upcoming lectures will be given to you in well advance. All right. This unlimited access you get once you subscribe to Unacademy Plus. Alright, and no matter how did you get the subscription, all the things which I have just told you will get once you get the subscription. Alright, so you can download this Unacademy's learning app from Play Store, and after downloading you can subscribe for 1 month, 3, 6, 12 and 24 months. But 1 and 3, 6 months average price, if you can see per month, is higher compared to 12 and 24 months. So 12 and 24 months are the best packages you can subscribe for. But also let me tell you one information. This price which you can see after 10% discount for 12 and 24 months, 27,000 and 32,400, which are current prices and will be valid for a few days, right? After that there will be a price hike and new price list is out, and it is going to be applicable soon. All right. So if you haven't taken the subscription, then take it now. This is the time, this is the best time to buy it, okay? Let me tell you the new pricing also. So you can see this is the current price list, okay, which I was showing you in the previous slide, and this is the list of current, and this will be the list for 1 year and 2 year, and similarly 1, 3 and 6 months. All right, so you can compare. This is 27,000 is for 1 year now, and it is going to be 34,650, that too after 10% discount. All right, these are discounted price only. All right, and similarly you can compare 12 months, 24 months, which is very low now, 32,000 only. It is going to be 50,000. okay, so guys, hurry up, buy it, take it, okay, take the subscription. It's very cheap now. Alright, so I hope it is clear. And one more thing, you can get 10% discount using my code JEET1. So use this code and get instant 10% discount. Alright, now let's begin the session. Alright. Okay, so first let me tell you some important points. Important points means, see this expression, whenever you see x square plus 1 upon x square, okay, you can write this expression as x plus, you can write this as a perfect square, okay, x plus, so this is an important expression, let me tell you about this. So x square plus 1 upon x square is basically can be written as x plus 1 upon x the whole square minus 2, alright, or you can write x minus 1 upon x the whole square plus 2. So both ways you can write this expression x square plus 1 upon x square. So this is very important. We are going to use this expression today in many questions, okay. So I am telling you this about this in the beginning only, alright. You can also relate these two expressions, so these two. So whenever you have x plus 1 upon x square, but you need x minus 1 upon x whole square, so you can interchange them by using this relation. X plus 1 upon x the whole square is equal to x minus 1 upon x the whole square plus 4, okay. Or you can write x minus 1 upon x, if you want to replace x minus 1 upon x whole square in terms of x plus 1 upon x whole square. So you can write x plus 1 upon x whole square and send this minus plus 4 to right hand side, so it will be minus 4, alright. So you can interchange. You can write x plus 1 upon x in terms of x minus 1 upon x, or x minus 1 upon x in terms of x plus 1 upon x. And similarly, x square plus 1 upon x square in terms of any one of the two, either x plus 1 upon x square or x minus. So which expression will be used when we'll talk about this? Okay, let's start the first example. Now see the first example. In this you can see this is a perfect square, alright, and this is perfect square of x plus 1 upon x. But in here you can see the second term is 3 by 2 minus 3 by 2 times x minus 1 upon x. Now if it would have been x plus 1 upon x here also, here in the second term, then we can put x plus 1 upon x is equal to t, right? But because it is x minus 1 upon x and we can't change x minus 1 upon x, but we can change x plus 1 upon x whole square. Whole square should be there, then you can change it. You can change this also, but under root will come there, right? So we don't need under root. We want to solve it keeping it rational only, right? So let's change this one, x plus 1 upon x whole square, using the same formula which I have just told you, this one, right? So we can use this formula and we can change it easily, alright? So let me write it. You can write this x, alright, so you can write this expression as x minus 1 upon x the whole square plus 4, alright. So this is nothing but x plus 1 upon x the whole square minus 3 by 2, and then x minus 1 upon x is equal to 4. So this way you can write this expression, you can change this expression. Now you can cancel this 4 and 4, so it is very simple equation. X minus 1 upon x you can put is equal to t, so it is going to be t square minus 3 by 2 t only, right? It's very simple, right? So you get t is equal to 0 or t is equal to 3 by 2. Now you need to solve it for x. So finally we'll put the value of t as we were doing in the previous session also. So put the value x minus 1 upon x is equal to 0. This is the first equation. So from this you'll get x square is equal to 1, and then you can write x is equal to plus minus of 1. Alright. Second is x minus 1 upon x is equal to 3 by 2 multiplied by 2x. So you'll get 2x square minus 2 is equal to 3x. Alright. So you'll get this 2x square minus 3x minus 2, and you can factorize this middle term, split the middle term. So you can write minus 4x plus x minus 2 is equal to 0. So you'll get one factor as 2x plus 1 and other as x minus. So I'm directly writing it, okay. you can use this. You can pair these two terms and these two terms, and then you can factorize. All right. So two values you'll get. X is equal to 2 is the first value, or x is equal to minus half as the other value. In 2 you have already got plus minus of 1. So in total you are getting 4 values. All right. So this is one example. Now let's do the another one. All right. So in this, what are we supposed to do? How do we start? Just have a look, think about it, and then I'll tell you. All right. All right. So now you can see this x square, probably you have got it right. So x square plus 1 upon x square, as I have told you, can be written as x plus 1 upon x the whole square minus 2, or x minus 1 upon x the whole square plus 2. So which formula we need to use? Obviously x plus 1 upon x. We need to express this in terms of x plus 1 upon x, because you can see second term is x plus 1 upon x. Alright. So according to second term, we'll change it to x plus 1 upon x the whole square minus 2. Alright. And again put the brackets, minus 27 into x plus 1 upon x. Also simultaneously you can put x plus 1 upon x is equal to t. So we'll solve this equation in terms of t. So it will be 9t square minus 18 minus 27t and plus 8 is equal to 0. So finally you'll have 9t square, and this is minus 27t. Alright, and then you can add these two terms, so it will be minus 8. Alright. Okay. So now you can use some split the middle term. Product should be 72 and sum should be minus 27. Alright. So minus 72. So this should be the product. Now think about two numbers. So think about two numbers which you can use in this. Alright. So then you can split this quadratic. Alright. So just get the combinations of this like 9 into 4, 36, and you can use, but 36 won't work because it is let me check this number, plus 8, 18. So I think I did something. This will be minus 10. This is 10. Alright. So last number is not actually 8, it is so it is minus 10. Alright. The sum should be 90 actually. Okay, 90. So now you can do it easily. This is 30 minus 3, 27 you can write. So 9t square minus 30t plus 3t. Alright, plus 3t minus 10 is equal to 0. So now you can see 3 is common. So 3 is common. So it will be 3t minus 10, and then plus 1 is common, 3t is common. Right? Plus 1 is common, so it will be 3t minus 10 again is equal to 0. So now you can write the factors. It will be 3t minus 10 into 3t plus 1 is equal to 0. Further you can write t is equal to 10 by 3 or t is equal to minus 1 by 3. So now further you can solve by putting the value of t. So t is x plus 1 upon x is equal to 10 by 3. Okay, so let's solve it. Multiplied by, let's solve this first quadratic. Alright, we have put the value of t in this. Alright, in this. So this is first we'll solve, and this will be the second. Okay, so second we'll solve later. Let's solve this first one. So multiplied by 3x. So by multiplying by 3x, it will be 3x square minus 10x and plus 3 is equal to 0. Alright. So I hope it is clear. Now I can split this 90 minus 90 minus t. So finally you'll get 3x minus 1, and when you write 3x minus 1, it will be x minus 3. Alright. is equal to 0. So you get two values. So x is equal to, from this you'll get x is equal to 1 by 3 or 3, alright. So this is good because you can see this expression is x and then reciprocal of it here. So obviously you get one root as a and another root as 1 upon a. Whenever you have such equations in which equation is written like x plus 1 upon a, so it's symmetric. Second is this. Second equation was t is equal to minus 1 by 3. So second will get x plus 1 upon x is equal to minus 1 by 3. Let's simplify it, multiply it by 3x, so it will be 3x square plus x, alright, plus 3 is equal to 0. So multiplied by 3x, and this equation has imaginary roots, right? Because you can see discriminant of this equation is less than 0. 1 minus 3 into 3 into 4, alright. So imaginary roots, and we need only real values, so we'll leave this equation, alright. We can write imaginary roots if required. If question will ask us to write the imaginary roots also, we can write imaginary roots also, just by applying the formula minus b plus minus of under root of b square minus 4ac upon 2a. Alright. Let me work on this twice again. So we have another form, another example. Think about it, how to do it. Okay. Let's see if you can think about it. You can try for a minute. I'll tell you after that. Yeah. So I hope you're getting it right. So this is convertible to quadratic, and clearly we can see that x square. Clearly we can see that if I put x square plus 5x is equal to t, right? Then this equation will become t square minus 2t minus 24 is equal to 0. Alright? Very simple. And now you can factorize it. So 6 into 4, right? 24. So you can write this t square minus 6t minus plus 4t minus 24 is equal to 0. Alright. So now you can write the values of t. Now you can put the values of t. It will be t minus 6 and t into t minus 6 plus, you can take 4 common from this, it will be t minus 6 is equal to 0. Alright. So finally you have t minus 6 into t plus 4 is equal to 0. I'm also checking my voice, so that's why I'm slightly slow. I'm just checking the sound also, if it is proper or not. So I'll get t is equal to 6 from this, or t is equal to minus 4. Alright. Now finally you can solve for, just put the value of t in this. So finally you can write. So finally you can solve x square. This will be your first equation, x square plus 5x. X square plus 5x is equal to 6. So minus 6 is equal to 0. This will be the first one. Alright. And simplify it. So it will be x minus, you need to write this x plus 6 into x minus 1. Alright. Easy to factorize. You'll get x is equal to minus 6 or x is equal to 1. Similarly, you can solve second also, x square plus 5x is equal to minus 4. So plus 4 is equal to 0. And from this, you'll get x plus 4 into x plus 1 is equal to 0. So you'll get x is equal to minus 1 or minus 4. All right, so I've got 4 values. This was easy, nothing to do much, nothing to think about. I mean, think about any other type. This was straightforward. Just put x square plus 5x is equal to 3. Although it's a fourth degree equation, but it is simple, right? All right, so this is the fourth degree equation we need to solve. This is the type 1. So now we are going to learn 4 types of fourth degree equations which are convertible to quadratic. All right, so this is the first type. Let's see how to do it. Let's see the pattern first of all. So you can see coefficient of x raised to 4 is a in this, and constant term is also a. Okay, so you can see the symmetry from last and first. Coefficients will be same. Yes, coefficient of x and coefficient of x cube, they are same magnitude wise. It can be plus minus of b here, right? It can be plus b, it can be minus b also. They should be same magnitude wise, and c can take any value, positive or negative, so no worries about c. So that is the pattern. If you see this fourth degree equation from the beginning or from the last, you can see coefficients are same. Okay, second coefficient and second last coefficient can be of opposite signs as well, right? But same in magnitude. That is the main thing. First and last should be of same magnitude, same sign and same magnitude. All right, so that is the pattern. For example, first let us discuss how to solve it. Okay, so in this case we will divide this given equation by x square. First step is this. So after dividing, you'll come to know what is going to happen. All right, we have already done this thing. So ax square, this will become bx, plus this will become c, and this will become plus minus of b upon x when you divide it by x square, and last term will be a upon x square. See, now what you need to do is you need to club these two terms, first and last. Okay, so you can take a common, and it will be x square plus 1 upon x square, right? Now you can club b, second and second last also, so it will be b times of x plus minus of 1 upon x. All right, now plus c is equal to 0. Now this expression, you know what you need to write. If it is plus, you'll express this in terms of x plus 1 upon x whole square. If it is minus here, you'll express this in terms of x minus 1 upon x whole square, right? So I'll write both. You can write this x square plus 1 upon x square according to these two signs. So according to these two signs, I'm putting the value here. So first, let's put with positive sign. So x plus 1 upon x, the whole square, minus 2, all right? But if it is negative sign, so you need to take minus 2 and it will become plus 2 here, right? So this will be the way to solve it, plus b into x plus minus of 1 upon x plus c is equal to 0. Now you can put x plus 1 upon x or x minus 1 upon x is equal to t, and then further you can solve it. Okay, so we'll do one example after this. I hope it is clear. Now let me explain this again. Whenever you have first coefficient and last coefficient same, second and second last magnitude wise same, plus b or minus b might be there in the second last term, and middle term can have any coefficient, So in such case, just divide the fourth degree equation by x square, and after dividing, just club first and last term, second and second last term, and this your middle term will going to be constant. All right, then you can express this equation in terms of quadratic in x plus 1 upon x whole square or x minus 1 upon x whole square. All right, so that was the type. Let's solve one example. This is one example. Based on this, you can see this is 2 and this is also 2. Here it is 1, coefficient of x cube, and here it is also 1, same sign, and this doesn't matter what is this number. So immediately divide by x square. All right, so divide by x square, it will be 2x square plus x minus 11 plus 1 upon x plus 2 upon x square. All right, now club this first and last term, second and second last term. So it will be 2 times of x square plus 1 upon x square plus x plus 1 upon x minus 11 is equal to 0. All right, so now it is going to be, this is going to be 2 times of x plus 1 upon x the whole square minus 2, alright. Let's express this in terms of x plus 1 upon x. Plus x plus 1 upon x minus 11 is equal to 0, alright. So finally you can write 2 times of, put x plus 1 upon x is equal to t at this step only. So it is, this quadratic will become 2t square minus 4 plus t minus 11 is equal to 0. Finally you can write 2t square minus 4t minus this, you can see, not 4t, I'm sorry, this will be only t. So t, and then minus 4 and minus 11 is minus 15. So this will be minus 15. Is equal to 0, alright. So now you need to split the middle term. Product should be 30 and minus 30, and sum should be minus 1, okay. So 6 and 5, alright. Let's split the middle term. So it will be 2t square minus 6t plus 5t minus 15 is equal to 0. Now you can solve it easily. Just take 2d common from this. It will be t minus 3, alright, plus 5 common from last two terms. So it will be t minus 3 is equal to 0. So you'll get t is equal to 3. This is first value, or minus 5 by 2 from the second one. This, we put this is equal to 0, right? Now what was our t? T was x plus 1 upon x. So x plus, let's solve this, x plus 1 upon x is equal to 3. So again you'll get x square minus 3x plus 1 is equal to 0. So you can write x is equal to, you need to apply Shridharacharya in this formula. So 3 plus minus of under root of b square minus 4ac. So 9 minus 4 is 5, right? Divided by 2. So that will be the answer. I hope it is clear. Now let's solve the other one, where is x plus 1 upon x is equal to minus 5 by 2, right? This will be the second value of t. So put x plus 1 upon x is equal to minus 5 by 2, and then multiplied by 2x. So it will be 2x square plus 2 is equal to minus 10x. No, sorry, minus 5x. It will be minus 5x, alright. So minus 5x, let's put minus 5x, alright. Now again solve it further. So 2x square plus 5x plus 2 only, right? Then you can split the middle term. So 2x square plus 4x plus x plus 2 is equal to 0. Then take common, so it will be 2x plus 1. I'm directly writing the factors, okay? X plus 2 is equal to 0. So you'll get x is equal to minus 2 and x is equal to minus half. So these are the two values you're getting from the second equation, and these are the values you're getting from first one. So total 4 values, right? So I hope it is clear, right? Now let's solve the another type. So this is another type. In this, expression is given, equation will be in equation will, you can see equation is written as a product of 4 linear factors, x plus a into x plus b into x plus c into x plus d. But right hand side is, it is not 0. E is not equal to 0, because if e is 0, it will be very simple. X will be, x values of x will be minus a, minus b, minus c, minus d, right? Directly can write the answer. But right hand side, it is not 0, and there was just one more condition. Sum of these two numbers, if I consider with sign, so it is plus a. So plus a and say plus c, all right. Sum of the constants in the in first and third term, first and third, or first or second, or first or fourth, take any two, all right. Doesn't matter. I've just taken it randomly. Sum of constants in two factors should be equal to sum of constant in remaining two factors, okay. So remaining two in this case, which I have connected, are second and fourth. So that means it should be like a plus c is equal to b plus d. That is the condition, okay. If a plus c is equal to b plus d, if this is there in the given equation, then you can convert this into a quadratic, okay. Let's see how. Okay, so this condition is given, okay. This must occur. So we will multiply first and third and second and fourth, just multiply them, expand it, I mean. So expand it, multiply first and third. So it will be x square plus a plus c into x, all right. Can you see this? A plus c, that is going to be used, and plus ac, all right, into Now multiply second and fourth, so it will be x square plus c plus d into x, all right, plus cd. Now can you see that this whole term x square plus a plus c into x and x square plus a plus d into x, these two are same, right? So let's take this is equal to t. This will also be t, right? Because a plus c, because a plus c is equal to c plus d. All right. So I hope it is clear. So we can write t plus ac into t plus cd is equal to e. Now you can expand it and it's a quadratic in t, so you can simplify it and you can solve it easily, right? So it is going to be t square plus a plus d into c into t. Okay, this will be the coefficient plus a b. Okay, I think I have done one error. This is, sorry, b plus d. Okay, b plus d, bd. So this is bd. All right, this is bd. So b plus d was given equal to a plus c. This rest is okay. I just had written c in place of b. Okay, otherwise everything is fine. So this expression, these two are still same. So you're putting this is equal to t. This will be bd. So it is going to be. Let me correct this also. Last step. All right. So it is going to be t square plus ac plus bd into t plus abcd minus e is equal to 0. All right. Now you can see this quadratic. We can solve it. We can find the value of t and then put t in this equation. Right. This is t and solve further for x. Let's take one example based on this. Okay. So can you see which sum of which two numbers is equal to remaining two numbers? So in this case, you can see 1 plus 2, no. 1 plus 3, no. 1 plus 3 is 4, 4 plus 2 is 6, so no. So 1 plus 4, all right, plus 1 plus 4, that is 5, and 2 plus 3. So in this, you need to combine first and fourth, second and third. Club this. So that means multiply these two. Multiply, expand it, I mean. So if you expand it, it will be x square plus 4x plus 1x is plus 5x, all right, and plus 4. So this is the first quadratic. Second, it is going to be x square plus 3x plus 2x, so plus 5x and plus 6, all right, is equal to 8. You can see this will always be common, all right. It will appear automatically if numbers are given. So you can put x square plus 5x. In fact, you can take also 4 along with this. So you can take this also as equal to t, x square plus 5x plus 4, all right. So that will be t and this will become t plus 2. So in that way also you can solve it, okay. So I'm taking x plus 5x, x square plus 5x is equal to t. So now you can see it is, okay, let's take 4 also. Because you don't know which is going to be simple. There's no much difference. But let me show you this one also. If you take plus 4 is equal to t, then this will be t, this whole thing will be t, and then second expression will be t plus 2, all right, is equal to 8. And you are going to get it t square plus 2t minus 8 is equal to 0. Now I can split this middle term easily. So t square plus 4t minus 2t minus 8 is equal to 0, and get two factors. T plus 4 is one factor and t minus 2 will be the another factor, all right. So now you have got the values of t. So t is equal to minus 4 or t is equal to 2. Further, we need to solve it for x. So xk, let's put the value of x. Okay, we'll solve it here. So first equation is going to be x square plus 5x plus 4 is equal to minus 4. So you'll get this x square plus 5x plus 8 is equal to 0, which will give you imaginary roots, all right. Imaginary because you can see discriminant is less than 0, all right. So another, what is the second equation? This was the first one. Second case is going to be x square plus 5x plus 4 is equal to 2, all right. So you'll get this x square plus 5x plus 2 is equal to 0, and it is going to be x is equal to, now you need to apply formula, right? Obviously you have only one option. Minus 1 minus 5 plus minus 25 minus 4ac, so minus 8 divided by 2a. So you'll get two values of x, minus 5 my under plus minus of under root of 17 divided by 2. All right, so that is that is going to be the answer. All right, so I hope it is clear. Now we have done two forms are remaining, so we'll discuss remaining two forms. uh, this is the form. First, you think about it, how to solve it. One more condition will be given in this. First is this, that e is not 0. Obviously, e should not be 0, otherwise this x square term will vanish. Okay, so e is not 0. And again, like previous form, their sum of two constants was equal to sum of remaining two constants of the given factors, linear factors. In this, product of two constants, okay, will be equal to product of remaining two constants of the factors. So that means, let me give you AC is equal to BD in this case. Okay, suppose AC is equal to BD is giving. Now you think about it. Okay, you think about it. I'll tell you after 2 minutes. So let's see if you can crack it. All right, so I hope you are able to figure it out. Let's see. So in this case, uh, like the previous form, I'll multiply the first and third, in which product is AC, and the remaining two, in which product is BD, which is equal to AC, right? And see what are we going to do after that. So I'll write x square, it is x square plus A plus C into x plus AC. Okay, we need to use this in this case. Okay, but let's see how to use it. And the second quadratic expression will be x square plus B plus D into x plus BD. All right, is equal to, you can see x is also here. Even if you put this is equal to t, this won't become t first thing. Okay, first thing is this, because a plus c is not given equal, a plus c is not given equal to b plus d. AC is equal to BD. So how to use it? Okay, see, we are going to divide it by x square. This whole equation we are going to divide by x square. And how would we divide? We divide this factor by 1x and this factor by another x, because we have 2x now. So I'll put 1x in the denominator of this first quadratic and another x in the denominator of second quadratic. So this first is going to become, okay, I'll write first step like this: x square plus AC plus a plus c into x. 1 minute. A plus c into x plus AC, and the second will be, okay, divided by x, put 1x, and then x square plus b plus d into x plus bd. All right, and again divided by x only, right? This is going to be e. Let's see how to solve it. If you divide this first quadratic by x, divide individual terms, so it is going to be x, and last term is going to be AC upon x. So I'm writing this next to the first term, and then a plus c will be remaining, so write it as a constant, AC, a plus c. Similarly, in the second quadratic, first term is going to be x, third term going to be bd upon x and plus b plus d. So I hope now you can see it, right? Is equal to e. So these two expressions, this and this, these are equal, right? X plus ac upon x is equal to x plus bd upon x. Why? Because AC is equal to BD, it is given, right? So whenever you can see numerical values, so in numerical values, it will be automatically visible to you, right? Here I am putting the condition that AC is equal to BD, all right? So that's why I'm showing you that x plus AC upon x is equal to x plus BD upon x. So now you can put this is equal to T, this is equal to T. So this quadratic is going to be, this equation is going to be T plus A plus C into T plus B plus D is equal to E. Now you'll open it, you'll get a quadratic in T, then you can find the values of T easily and put the values of T in this equation, okay? So we'll solve one equation. So I'm giving you this equation to solve because I have told you the procedure, so I hope you can solve it. So take 2 minutes time, solve it, then I'll simplify it, then I'll solve it for you, all right? Try this. Try this particular sum. All right, so I hope you can figure it out how to start. Let's see. So first of all, you should notice that there are four linear factors in product, okay? So it might be the second form or the third form, all right? But you can see x square right hand side. So if it is only constant, then it will be second type. And if it is with constant with x square, that means it is going to be of third type. So when it is of third type, then just try to figure out two numbers whose product is equal to remaining two numbers. So if I take 2 into 3, it is 6, but 8 into 12 is much more than that 6, right? Then you can try first and third. So it is 16 and 3 and 12. No, this also won't work. Then let us try first and fourth, the least and the biggest number, all right? And the numbers in between, 3 and 8. So 2 into 12 is 24 and 3 into 8 is also 24. Okay, so this is going to work. That means club this first and last term. So it is going to be x square plus 2x plus 12x. So that is 24x plus 24, all right? Sorry, 14x, I'm sorry. 12x plus 2x is going to be 14x. 14x plus 24. And the second is going to be x square plus 3x plus 8x, so plus 11x plus 24, all right, is equal to 4x square. Now, what was the next step? Next step was to divide it by x square, all right. So we'll divide 1x here and this second factor by 1x and here by x square, all right. So this x square and x square will get cancelled and it is going to be x plus 24 upon x plus 14, all right, and second it is going to be x plus 24 upon x plus 11, all right, is equal to 4. So now you can take, either you can take this whole thing is equal to t, you can take this is equal to t, or only x plus 24 by x is equal to t. So it's better if you take this whole thing as t, all right. So let's take, let x plus 24 upon x plus, I'm taking plus 11 as well, is equal to t. So it will be, this first factor will become t plus 3, and second is going to be only t is equal to 4, all right. Then we can simplify it. It is going to be t square plus 3t minus 4 is equal to 0. Now you can write the values of t easily. So t is going to be minus 4 and plus 1, all right. So I'm directly writing the values of t, okay, minus 4 and plus 1. You can factorize and write the values. You can split this. You can write 3t as 4t minus t, okay, 4t minus t. So first one factor will be t plus 4 and the other factor will be t minus 1, all right. So in that way you can factorize it. Now let's put the values. X plus 24 upon x plus 11 is equal to minus 4. Okay, let's put this. Okay, so let's simplify this quadratic and then we can solve the another one also. This is minus 4 only. It's minus 4, all right, minus 4. Okay, so multiplied by x, you'll get the quadratic. So it is x, you can take this 4 with 11, so it is going to be 15, all right. So it is x square plus 15x plus 24. This is the first quadratic. Now split the 15. So you can write, can you split 15 so that product is 24. Let's check the values. Yeah, minus 4, perfect. So we have taken this is whatever. Okay. So let's see if you can split it. 12 into 2, no, not possible. All right, so that means you need to apply formula. If you will apply the formula, then it is going to be minus 15, all right, minus 15 plus minus under root of 225. So 225 minus, all right, 4ac. So this is going to be 96 divided by 2a. So these are the values of x. So it is going to be minus 15 plus minus of under root of, so if you subtract this 96, okay, 96, so it is going to be 129, all right, 129, yeah, 129, your odd numbers, okay. So this is going to be the values of x, all right, values of x in this case. Now we have another quadratic also. Let's solve that one also. Let me also check the calculation once. So we divided this by 12 into 2, 8 plus 3, 11, 20, 12, 14, perfect, 24, perfect, x plus 24 upon x plus 14, x plus 24 upon x plus 24, x 24 upon x plus 11 is equal to t, and there's t plus 3 into t is equal to 0, so t square plus 3t minus 4, so t minus 4 plus 1, and this and this. All right, so perfect. Now we have another quadratic. So another quadratic to solve. I think you can solve it. X upon 24 by x, I'll write it for you, plus 11 is equal to, what was the second value of t? Was 1. So it is 1. So let's simplify it. It is going to be x square. Now this will be 10. So plus 10x, all right, plus 24 is equal to 0. So it will be x plus 6 into x plus 4, x plus 6 into x plus 4 is equal to 0. So it is x is equal to minus 6 or minus 4, two values, all right. So this is going to be the answer. All right, so let's move to our last form. Okay, so this is our last form. All right. This is our last form. So think about it. I'll tell you what to substitute in this. You just think for a minute and then I'll tell you, all right? Think for a minute, then I'm going to tell you about this last form. Oh, this is actually 4. It's not 2, it's 4, and this is also 4, all right? So I'll write it correctly. It is x minus a raised to 4 plus x minus b raised to 4 is equal to c, all right? This is the equation. It's a fourth degree equation, and this particular, to solve this particular type, whenever, even if you have b minus x raised to 4, always write this in terms of I mean make the coefficient of x positive. So write this as x minus b raised to 4. Okay, you can interchange, no problem, because power is even. So whether you write b minus x or x minus b, both will be same. Okay, so it might be given, this equation might be given in this form also, right? X minus a raised to 4 plus b minus x raised to 4 is equal to c. So what you need to change, you need to change this one. You can write this equation as the given equation, right? Because you can interchange b minus x and x minus b easily. All right, so let's see what to do in this type of quadratic. So you need to use this substitution. Take the average of these two numbers. Okay, so put t is equal to, this will be the substitution, t is equal to x minus a plus 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 x minus b divided by 2. Okay, so you need to put this one. You need to put t is equal to x minus a plus x minus b divided by 2. Okay, so what will happen if you put this number? I'll tell you through an example, and then you will come to know that easily we can factorize it. Okay, otherwise it is, if you directly expand it, it is going to be very lengthy. Okay, very lengthy. So do not try that. Okay, it is going to be like, it will take then 5 to 10 minutes, right? 7, 8, 9 anything, and that also won't guarantee that you would be able to solve it. It won't be guaranteed. Okay, so in this way you can convert this into a quadratic and then you can solve it. So I'll give you one example and you can see that example. Let me check my voice finally one more time, and then I'll start telling you the solution of this. All right, so this is the form. Okay, this is the example based on the previous form, fourth form. All right, so as I told, this is perfectly written. Can you see coefficient of x is positive here and positive here also? So you need to put t is equal to t or y or z, whatever variable you want to take, you can take it. So t minus 1, okay, plus, sorry, t is equal to x minus 1 plus x minus 5, this whole divided by 2. All right, this whole divided by 2 is going to be x minus 3. All right, so that means you need to put t is equal to x minus 3. So let's put it. So x minus 3 minus 1 raised to 4, see, this will be the first expression, plus x minus 3 minus 5 raised to 4 is going to be the second expression, is equal to 82. Okay, so now first one you can write is going to be x minus 4. 1 minute. Oh, what am I doing? Sorry. We need to put the value of x. Oh, I'm sorry. We need to put the value of x in terms of t. I was writing. Okay, so Actually the value of x in terms of t, I have not written it here, x is equal to t plus 3. Okay, so we need to substitute x in terms of t, so x is going to be t plus 3. So this is the value of x which we need to put in this equation. So it is going to be t plus 3, all right, minus 1 whole raised to 4 and plus t plus 3 minus 5 whole raised to 4 is equal to 82. All right, so first equation you can see is t plus 2 whole raised to 4, and second is going to be t minus 2 whole raised to 4. So whenever you put the average of these two numbers as t, this is going to happen. One expression will become x minus a, another will become x plus a. Okay, so that is the first step. We have brought this equation in this particular form, in which first expression is x minus a and another is t plus a or t minus a, or you can say x plus a or x minus a. All right, now what to do? Now second step is still you need to be careful after that also. Now see how am I going to solve it. I'll solve t plus 2. I'll write this first expression as t plus 2 the whole square and again square. So first I'm going to do squaring, and t minus 2 the whole square and whole square. So you can write this power 4 as square of perfect square. Okay, is equal to 82. Then you can expand it, so it is going to be t square plus 4t plus 4. Okay, I'll write this as t square plus 4 plus 4t. Okay, so write this 2ab term in the end. Why, I'll tell you. So this the whole square plus, in this it is going to be t square plus 4. This term is going to be same, t square plus 4. The only difference is now I'll have minus sign, and second term will also be same, 4t. Okay, so what to use? How to use this point? Now you can say this the last step. In this step, equation is written in this form: x plus y the whole square plus x minus y the whole square is equal to constant. So easily if you expand it, 2xy term will get cancelled. All right, and you'll get x square twice of this equation. If you expand, you are going to get 2 times of x square plus y square is equal to k. Okay, so directly you can use it and you can write the expression. So this is your x and this is your y. So x plus y whole square, x minus y the whole square. So you are going to write t square plus 4 the whole square plus 4t the whole square, and this whole into 2 times of x square plus y square is 82 now. And further up, it's very easy. Now it is very easy, you can solve it easily. It's a quadratic now, in fact biquadratic, but very simple biquadratic. Biquadratic is very easy to convert. Just put x square is equal to t. Okay, so cancel 2 left hand side and right hand side and expand this quadratic further. So you are going to get t raised to 4 plus 16 plus 8t square, all right, plus 16t square is equal to 41. All right, is equal to 41. If you cancel 2, it will be 41 right hand side. So finally you will get this equation: t raised to 4 plus this one. Okay, 16 plus 8 is 24, so 24t square, and the 16 and minus 41. So if you bring 41 left hand side, it will be how much? 425. So minus 25 is equal to 0. You can put t square is equal to u, or otherwise directly assume t square is equal to u. It's a quadratic only in terms of t square. So just write t raised to 4. Split the middle term. So you can write t square plus 25t square, t raised to 4 plus 25t square minus t square minus 25, and you can factorize it here only. So it is going to be t square plus 25 into t square minus 1 is equal to 0. So this will give you imaginary values of t, so just leave it, and this will give you 2 values of t. So t square minus 1 is equal to 0 will give you 2 values. One is t square is equal to, solve this, t square is equal to 1, and you all know that t is plus minus 1. So you have got t is equal to plus minus 1. Now let's see what was your t. So you are getting 2 values of t. Just put t in this equation and you get x. So if you put t is equal to 1 plus 1, it is x is equal to 4. And if t is equal to minus 1, it is going to be 2. All right, so you're getting two real values, and from this equation you'll get imaginary values. So leave those values because we need only real solutions. All right, so this was the last form. Okay, this was the last form, and this becomes very lengthy if you want to use this particular substitution. Okay, this particular substitution, and also follow these steps. Okay, how to expand x plus y whole square plus x minus y whole square, just to save time. So you can save a lot of time if you practice these steps. Yes, this session is slightly difficult because we were doing polynomials convertible to quadratic, so it was not that simple like previous session in which we were doing simple equations which were easily convertible to quadratic. There was no manipulation involved in those equations. Directly just check, oh, this is t square, put this is equal to t, right? Not like that. So but this is important for advanced, so you need to do it, you must learn it. Now we'll continue quadratic equations from next session also. So from next session we'll do nature of roots. Okay, so in nature of roots we'll see real roots, conditions for real roots, imaginary roots. Okay, and also rational roots and also integral roots. Okay, so we'll do all these things in next session. Next session tomorrow. Rational, real roots, imaginary roots, rational roots, and integral roots. Okay, so in upcoming sessions. All right, thank you very much for watching this video, and like and subscribe Unacademy Plus. As I told you, price is going to be hiked soon, so price is increasing. So buy the subscription if you haven't taken this yet, and use my code JEET1 to get 10% discount. All right, and also subscribe this channel. Let's crack JEE in English. All right.